Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss the first three problem asked in today's Codeforces Round 1057. So let's start with the first problem. It says there are an apple trees that are arranged in a circle, right? And each apple tree contains one apple, and each apple has a beauty of bi, right? And at each tree, what you can do, you can either eat the apple or you can skip it, right? And after making the choice, you move to the next tree, and this movement has to be in a circular order, so from I to I plus 1, and then from n back to 1. So let's say you started your movement from tree number 1, so it has to be 1, then 2, then 3, then 4, then 5, then n, and then n back to 1, right? So yeah, that is the movement part. Now there is a condition there. So let's say in certain moment, you want to eat the apple which is present at the tree, right? So the condition is its beauty has to be more than the beauty of previous apple you ate. That's the condition it has, right? And at the end you have to find out how many number of apple which you can eat, right? So yeah, so just one thing. So since we know that the beauty of any apple has to be more than, like, if strictly greater than the previous apple it has, right? So there will never ever be two apples of same beauty which we eat, right? So that was one thing. So in this problem, so let's say there are n number of trees, 1 2 3 4, right, up to n minus 1, then n, and then 1. So this is the movement. You start from 1, then 2, then 3, right? And one more condition, this number of movements is infinite. You can move this infinite number of times, and we know that uh, my current beauty b of I has to be more than b of j. So b of j is the previous beauty of, apple which you ate, right? So this is the previous one. So since we know that this has to be in increasing order, right? The beauty of apple which you ate has to be in increasing order, right? So none of the two beauty would be same. That was one thing. So it means that, let's say there are a number of apples there, right? So the first step, find all unique find all unique beauties find all unique beauties, because I know that none of the two beauties would be same, because it has to be in increasing order, because my next beauty has to be more than the current beauty. So first find all the unique beauty. The second step, this is my answer. The reason is, since the number of movement is infinite, you can move infinite number of times, then there must exist a certain order such that you kind of consume all the unique beauties. There is a way for sure. So if you think about it, this is pretty straightforward. So I don't think I should spend time explaining this part. So it's just a quick observation. So first step, find all the unique beauties, and that is your answer, right? So yeah, if you still find a way, so if you still don't understand how all the unique beauties is the answer, please write a comment. I'll explain there, right? So let's look at the code now. So here is the code. This is my input n, right? And I have, what I have done, I have created a set here. So in set, all the numbers are in a sorted order and they are unique, right? Sorting is not required here. I just need all the unique. So what I did, I just taken the input, like the beauty of the ith tree, and I just inserted into the set, right? So after this insertion, this set would contain all the unique beauties. So just see out that the size of this set, right? So the size of set essentially tells you the number of unique beauty it has. So for example, here if you notice here, so 5 4 2 1 2 3, the output is 5. So let's say I started from here, so I'll take 1, then 2, then 3, then I don't take 5, I will take 5 at the end, then I will take 4, then again I will come back to the second loop, and then I will take 5, right? So here see, I have taken 1 2 3 in the first step, In the second step I have taken 4, in the third step I have taken 5. So yeah, I hope you understand. So this is all about the first problem. Now let's look at the second problem. This is the second problem asked in today's contest. So it says you are given three non-negative integer x, y, and z, and you have to determine whether there exist three non-negative integer a, b, and c such that a and b is equals to x, b and c is equal to y, and a and c equals to z, right? And yeah, so if there exist a, b, and c, then see out as, otherwise no, right? So yeah, let's see how we can approach it. So in this problem we are given x, y, and z, right? So what we will do first, we will represent each x, y, and z into its binary representation, right? Since the number are only up to 10 to the power 9, so it can be represented in 32-bit number. So this is my LSB, this is my MSB. So this is my 0th bit, first bit, second bit, third bit, so on up till this 31st bit, right? So, and we know that we have to find out a and b such that these conditions are satisfied. So what I will do, instead of looking at this, I will divide into a smaller problem. If a and b is equal to x, I claim that ai and bi must be equals to xi. So xi means its ith bit. So instead of saying a and b equals to x, just check if the ith bit of a and ith bit of b is equal to ith bit of x is not, right? If that is true, I mean, if a and b equals to x, it means that all these 32 bits should be same, right? So that's why I have divided it into bit format. So I will check for each of the ith bit this condition holds true or not, right? So first I will find the ith bit of all x, y, and z. So to find the ith bit of x, what we will do a standard way. So x right shift I and 1, right? So this will give you the ith bit of x. Similarly, y right shift I and 1, this will give you the ith bit of y. And similarly, z right shift I and 1, so this will give you the ith bit of z, right? So this way we will get xi, y, and gi. So we know that this could be 0 1, this could be 0 1, this could be 0 or 1, right? So there are total 8 possible combination, right? So let's say this is xi, yi, and gi. So there are 0 0 0 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So total 8 possible combinations, right? Out of these 8 possible combination, only these 5s are valid. Only these 5s are valid combination. So first find xi, yi, and gi. So the ith bit of x, y, and g. Check if they are uh, a part of all, I mean these, so any one of these 5 way, then the ith bit is valid. So if any one of these 5 your xi, yi, and gi is, then it's a valid ith bit. Otherwise, similarly, say immediately return no. The reason is so if so in pen and paper, if you, so I actually found this 5 way among these 8 by writing in my code, sorry, by writing in pen and paper. So just do one thing. Let's say this is your xi, y, and gi, right? So try to, so if you try to find some ai, bi such that ai and bi is equal to x, bi and ci is equal to y, and ai and ci is equal to z. So if they are a part of this, so if they are one of these 5 valid, then it's okay, you can find a, b, and c, ai, bi, ci. Otherwise there won't be a way. So yeah, it would be a very long explanation if I try to do this in this video. So I would suggest try to follow this in pen and paper. You would like easily understand that these are the only possibilities we have, right? So yeah, let's look at the code now. So this is the code. right? So I took the input x, y, and z, right? So initially this is my answer. Now I'm going through each of these bits from 0 to 31st, right? I first fetch what is my xi, yi, and gi, right? So here I have called it a, b, and c. Now I check if the value of x, the ith bit of x, y, and z is a part of any one of them, right? Among these five. So I have stored it in a variable okay. So if this is not okay means there are not. So the ith bit of a, b, and c, x, y, and z is uh, not a part of like any one of these five. So immediately return answer, right? So otherwise your answer is going to be yes. Otherwise your answer is going to be no, right? So this condition should valid for all the bits, right? So yeah, this is all about the second problem. Now let's look at the third problem. This is the third problem asked in today's contest. So it says you are given n sticks, right? The ith sticks has a length of ai, and you want to choose a non-empty subset of these sticks and use them as a side of polygon, right? And each selected stick must be used entirely as a single side of the polygon, right? So it is not allowed that two or more sticks are joined to form the longer side. So each sticks is represents the single side of the polygon, right? And you have your goal is to form a polygon that is symmetrical and strictly convex and non-degenerated, right? So yeah, this is a really good problem. Yeah, let's see how we can approach it. In the third problem, we know that the polygon has to be symmetrical, right? Symmetrical means if you draw a vertical lines, your left side and right side should be a mirror image of each other. It means that there is a side of length, let's say x, on the left side. Similarly, one another side has to be on the other side of same length x, right? Then only they would be mirror image of each other. So what we will do here first, so we are given n number of uh, ages, right? So first what we will do, we will find all the pair of ages of having same weights, right? Same length. So right, so what we will plan to do, we will planning to have one of them on the left side and one of them on the right side, right? So we will create a map here to store the frequency of each of the weights is length, right? So let's say in this map I stored uh, length, right? Let's say the length is x and the frequency is f, right? So let's say the first condition, let's say the frequency is even, right? It means that uh, the length x age is present even number of times. It means that we can have so half of them should be present on the left side and half of them should be present on the right side, right? This was the first condition when f is even. The second condition, let's say if f is odd, right? So we will keep one copy uh, in some vector, let's say that is called uh, some remaining. So this is the remaining, yeah, leftover. Let's say this is called leftover, right? The leftover age, right? So we will insert one copy into here. So once you insert here, now f become even, right? So again we will keep half of the x length age on the left side and half of them on the right side. So there would be a leftover vector that essentially store what are the ages that are left, right? So so once you finishes this step, what you will left with the leftover vector, right? The leftover is what are the options we have. Now if you notice here, this is not sufficient, by the way. You have to find out the maximum perimeter of this uh, polygon, right? So currently once you finishes this step, you left with leftover, right? So what I'm saying here, so there are two ways. Among this leftover, either you take one or you take two edges. Let's see how. You cannot take more than two edges. The reason is, let's say I created a polygon or something like this and this. Let's say this is of length 2, this is of length 2, right? So I know that it has to be a mirror image of each other. So here there is just one possibilities. You have to take just one among this leftover and join it this way, right? So this is the case when you take just one. Now let's look at the second case. Let's say you have something like this on the left side. On right side, let's say you have this and this, right? Let's say the length is x, y and g. Since they are mirror image of each other, it has to be x, y and g here again. Now what I'm saying here, I can also take two edges among this leftover vector. First, I will join here and then I will join here. Let's say the length is some p and q. See, these are the two possibilities we have. Either you take one among this leftover or you take two edges from this leftover. And that's it. I hope you understand everything here. So this is the most critical part, right? So I don't think anything left to discuss. So one more thing, taking one is easy, but taking two edges among this leftover is a bit tricky, because this this leftover vector can contain m number of edges, right? So how do you pick the maximum two, right? You have to pick just two edges, right? So picking two edges could be tricky. So the way we do it, and one more thing, this polygon has to be convex, right? So in convex, let's say the total perimeter is sum, let's say, right? And let's say there is a edge called x. For let's say there is a edge who has the length of x. I claim that your sum minus x has to be greater than x, or your sum has to be greater than 2 into x, right? The reason is, if your sum is equals to 2 into x, so it's a straight line, or so it won't be a convex. So for convex, this condition must be satisfied, right? So if you understand that part, I think you can solve it now. So we know that we have to find out two edges from this leftover, right? So what we will do, we will first sort this leftover in an increasing order, right? So let's say this is my leftover array, right? The leftover array. So what I will do, I will start picking the ith one. This is the ith one, let's say. This is the ith leftover. And so before taking these two, let's say my total perimeter was sum, right? So sum what? By taking all the pair of same edges, right? So let's say this is my sum, this is my ith, and since they are in increasing order, let's say this is my jth. We know that sum is has to be greater than 2 into x, right? So what it means, it means that this sum plus I, so you have to find out the minimum sorry, the maximum j, such that your sum plus a of I, let's say this is my a array, a of I is greater than a of j. I hope you understand this part, right? So here what I'm doing here, the sum of all the edges excluding that edge has to be more than that edge. That's essentially what I'm doing here. This is my sum. I want to take two edges. So sum plus a of I has to be more than a of j. Then only this polygon would be convex. Since we know that this array is in a sorted order, so we can apply binary search here. So we can use lower bound, or you can do standard binary search low and high as well, but I have taken lower bound here. So I will take the lower bound for sum plus a of I, and I will try to find the maximum value such that a sum plus a of I is greater than a of j, right? I hope you understand this part. This part is very important part, right? So yeah, if you have any query, please write a comment, right? So yeah, let's see the code now. Here is the code of third problem. So this is my input n. Then I have taken input n number of length as an input, and I have incremented the frequency of that particular length in the map, right? So this is a map from for long to long. So I incremented the frequency of that length. Now I used a leftover vector, right? So as discussed in the explanation part, this is my sum and count. So sum is the sum of the perimeter of the taken length, and count is the number of edges which you have taken, right? So now I'm iterating through all the length from the map. So my length is it dot first and its frequency is it dot second. So initially I took all the edges, so count plus equals to f and sum plus equals to length into f frequency. But the thing is, if the frequency is odd, it means that there would be one leftover, right? So just insert that length into the leftover vector, and now decrement the sum and decrement the count, right? So sum minus equals to length and count minus equals to 1, right? So once this finishes, just check if count is 0. If the count is 0, it means that there is no pair possible. So there is no pair of equal length, right? So just see out answer. We know that there must be at least one pair of equal lengths, otherwise this polygon won't exist. So see out answer. Otherwise, just sort this leftover. So first check if the leftover is empty. If the leftover is empty, then you don't have to worry about picking one or two leftover lengths. So in that situation, just check if if the count is less than or equals to 2, it means that if the count is 2, essentially, since the count would be even for sure, right? So if the count is 2, see out answer, because the polygon has to be at least 3 number of edges, right? So if the count is 2, there won't be any polygon possible, so return 0. Otherwise return answer, right? The sum. If the leftover is non-empty, then you come to here, then there are 3 choices. Either you don't take it, so in that situation your answer is going to be sum, right? So your answer is going to be sum, or you take one leftover. If you take one leftover, then iterate through all the edges in the leftover. Just check if the age of that leftover is less than the sum, right? We know that the sum of any age has to be less than the sum of all other ages. So if that condition holds true, then just update the answer is equal to max of answer comma sum plus x. So this was the case when you take one leftover. And now the last case when you take two leftover edges, right? So iterate through I is equal to 0 to I less than and I plus plus. Now I will pick leftover of I as a one edge. So since they are in a sorted form, that's why I have used lower bound here. So my current sum is going to be sum plus leftover of I. Now I know that the length of the other edge has to be smaller than this, right? So that's why I used the lower bound here. So I used the lower bound for this sum plus leftover of I. I did index minus minus. Please try to code this by yourself as well. Then you would understand it better what I'm doing here. And please check out the explanation part. So if my index is greater than I, then it means that you can take the leftover of idx index. So just update the answer. Answer plus equals to answer is equal to max of answer comma sum plus leftover of I plus leftover of index. And at the end, return your answer, right? So yeah, this is the code, and here is the input, here is the output, right? So yeah, if you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.